Right, to get into it, I'm basically going to talk about memoization, something that if you work with React, you're either love or hate. So I'm going to cover the good, the bad, and the ugly. Then I'm going to touch on the new React compiler and explain what I see as the core lessons that we can actually learn from it. Well, at least from the little that we actually know so far. So, memoization. What is it? It's an optimization that involves storing data or a stable reference to a function in memory. Traditionally, it would be used for storing the result of like a complex calculation to speed it up. How would it speed it up? Well, every time you perform a complex calculation, it takes time. So rather than performing it every time, you can store the result of that computation in memory. So if you get the same inputs, it will just return you the stored result rather than recalculating. But remember, it's a trade-off. So it uses up space in order to save that time. So these are the classics in React that you'll be familiar with if you've been memoizing in React. Use memo, which is for data, memoizing data. Use callback, memoizes functions, and memo memoizes components. So what happens when you use these is basically it won't rerun them unless the things in the blue brackets, i.e. the dependency array, unless those values update. The dependency array is really useful. Number 1 and 2, memo and callback, have got an explicit dependency array, which gives you the power to say, only watch these values. And so it will only update if those values change. Number 3 has a kind of implicit dependency array, and those would be the props that are given to that component or its own internal state. And later we might come back to why number 3 isn't just always the case. Why not just wrap everything in a memo hook? But if we have time. So I thought one thing you might be asking at this point is, I thought memoization was meant to be for calculating speeding up complex calculations. So why do we use it like this? This is probably a pattern that you've seen quite a lot. Well, in React, we use it like this, and we should, in fact, use it like this, at least for now, because what happens when you give an unmemoized object to a provider, say a context provider or a parent? As some of you will know painfully from experience, what happens is a hell of a lot of work that probably doesn't need to happen. And that's because in JavaScript, data in the form of objects, arrays, and functions do not have stable references. That means that they are created new every time. And so this object, if I made another one that was identical, still the key is X, still the value is user ID, which we're going to suppose is a string or a primitive of some kind, then even though it's the same, and philosophically, a separate debate, but it's not pointing to the same place in memory, so React doesn't consider it to be the same thing. JavaScript doesn't consider it to be the same thing. In other words, all non-primitive values are strictly identical only if they point to the same place in memory. So do use it like this because it will prevent all the subtrees from updating, because React re-renders all subtrees or subscribing components when a prop changes. So, as I said, the value prop is recreated on the fly every time this context provider re-renders. So even though this one's trivial and I could pass it exactly the same string, it's technically going to be a new object, and that will, if it's not memoized, that is. And so every component that subscribes to this, imagine it is the user ID, because that's like a really useful one where you do want everything to re-render if the user ID legitimately changes, so that you don't have all of your data showing to someone else's if they happen to then log in. But what you don't want is if your same ID comes up, every single child to re-render. I.e., when I say re-render, reruns all of those functions and all of those child functions. And that can be really expensive. if you have a big tree, like this one. So use memo lets us use space in order to solve this problem. Basically, the analogy in this instance would be needing to check every single bauble on this tree to verify whether it is the same tree as your tree, i.e. your tree, or whether it's someone else's, when instead you could just have a label on it that says your name, and then you know it's your tree, and you can just check that label, and then it's fine. Let's say JavaScript comes along, puts a new label on it, and you go, now I need to check every bauble again. But it's a new label, but if it still says your name, and that would be the reference, then it's still your tree, i.e. the relevant change to watch out for, the one that would be in the dependency array, is whether the name on the tag has changed. And so that's the only thing we actually want to watch out for. So re-rendering is bad, and memoization is great. Well, some re-rendering is bad, or at least it can be bad, especially if the tree is really complex. But memoization has a clear, simple, and very effective use. The former example being a really good one, i.e. memoize the value object high up in the tree. Specify the relevant changes you do want to watch out for, i.e. save on what are often called needless re-renders. But re-rendering itself can't be bad, because re-rendering is what makes your UI reactive, i.e. React. It's what allows user events to update in the first state, like the UI in the first place. So we have to be more precise. Basically, needless re-rendering is when React goes and checks everything in the tree, like all the baubles, when it doesn't actually need to, so nothing changes. It doesn't get given to anyone else in the end, i.e. the virtual DOM doesn't actually apply any changes in the end. So this final slide is actually, I would say, the more nuanced perspective to have on it. So Memo is great, it's true, it is awesome. So awesome that it's in fact easy to get obsessed with it. I mean, they gave us hooks, right? Let's just like hang everything on those, right? Surely we'll only get performance gains everywhere. Well, let's very quickly look at an example that shows why memoization it's an extreme example, I'm going to grant this. So basically, in this component, what should happen is I press the next line, and this is a poem, the last poem that I wrote many years ago, but it's cyclical and uses very few actual tokens of words, but that's a separate point. So when I click next line, the only thing that changes is the final line, and that is the desired behavior. It does this in a slightly unusual way, and this does happen in practice, but in this example it is quite contrived, where basically it's using a local mutation, and that local mutations are happening here, i.e. we're doing a push. And so this extended data variable is the one which is pointing to the first variable, and then it pushes the next line onto both. So these actually stay in sync. And this example is derived from one that I saw in one of the React Forget, one of the few React Forget explanations by the core team. And so I thought, let's have a look at how bad this can get. Basically, in general terms, mutation is like a form, pushing is a form of mutation, and so it would be impure. So here is a version of this component, which I'm going to say naively memoizes rather than logically memoizes. So what happens here, I click next line, and oh my God, it just keeps adding. And nothing's changing at the top, but we could go totally insane here. And yeah, there's definitely too many words. It's not even a poem anymore, arguably. So what's happening there, right? So here is my impure memoization. What happens here is that the two variables that were created, basically, we're just memoizing them, just putting them in a memo, right? This one is only watching for the intro changing because that's all it cares about. The second one is only watching for the initial data and the next line changing. I wish it would stop trying to define everything. So what happens here is essentially the first memoized variable or data just doesn't change. The second one, however, when the next line changes, does rerun. So this memo block does rerun. And so it's still pointing to the unchanging initial line or lines. And when we click get next line, it adds on, it pushes the new next line to the initial one, the previous one. And then it keeps doing that. So again, the new one, the first one has been mutated, doesn't change, but we just keep adding to it. And so that's clearly not what we want. Oh yeah, I should mention that the reason why it adds on twice is just because it's in strict mode, and so everything re-renders double to try and actually weed out impurity like this. And so, yeah, the reason why this is wrong or buggy, because this is actually just a bug. This isn't just like use memo being a bit expensive. This is actually just like ruining the logic that you put in your initial component. And so essentially, it's ruining what was like fine local mutation. Local mutation isn't a problem if it's contained within a component, but in this example, it is. So then I made another pure version. And what happens when you click get next line here? Oh, just nothing changes. And that's because in this example, we're only showing the first line again, and we're telling it to recompute only if intro changes, and it just doesn't. So no matter how many times we click, it doesn't update. However, we still have a second data. So incidentally, I should mention that this one does work the way we intended it to. So in real life, I would use, well, something more like the extended data variable here rather than doing the internal mutation. But that's kind of not the focus at this point. So we can see that it can be a little bit dangerous. So maybe we shouldn't use it. And some people do think that we shouldn't use memoization almost ever unless you have drastically poor performance, which I think is a little bit too strong, because as we saw before, there are clear cases where it can just be used at the top level. That context provider is probably not going to get, like there's not going to be loads of extensions to the props of that provider that are really complex objects, hopefully. So there are good examples of just using it really well. So I think the moral of the story is memorize some things. You just have to remember what it's doing. It's caching data. So we need to be careful with the dependency array in particular. It's not always premature to optimize. You just have to memorize like with, thought. Except that it's also sometimes a little bit brittle, and the dependency array can break it. But we need to move on. So why do we care? The new compiler's coming. It's going to do all this automatically. And that's the really exciting thing, actually. And what is it that it's going to do? Well, for starters, automated memoization. Woo! What does that mean? Improved developer experience, because we write less code. That is the aim of our life, right? It also means improved user experience, i.e., we get improvements in the performance of our apps. They will be faster. So how's it doing it? Is it some kind of black magic? I mean, the source code isn't even public, so how can we understand anything about what it's actually going to do? Is it going to create bugs like the one that we saw before? Well, first of all, let's look at some first principles. What does it even mean to say a React compiler? What is a React compiler? And then we're going to look at some demos that the core team have given, which actually do show what it does under the hood. And that's really exciting because I think there are a couple of lessons we can learn from the compiler if we let it. Yeah. So briefly, in general terms, a compiler basically converts some symbols into other symbols. The symbols it converts into are usually more basic symbols, uglier symbols, but they're symbols that the machine can understand more quickly. JavaScript compilation, in particular, is just in time. It takes your ES6 or React code and basically compiles it to a lower level and then immediately executes it. What's really important here is that the React compiler is doing static analysis on the source code. So it takes a whole document or a block of logic at build time, when it's static, and tries to predict the program behavior. That is what static analysis does. And so, in other words, it doesn't just look at it line by line and try and transpile it into some other code. It is doing a kind of something more fundamental. What we know about it is that it is a low-level compiler specifically for React, and that means that it understands the rules of React and basically how JavaScript works. And so it builds an internal representation of your code at build time. And by understanding it, it can compile it into lower-level code that's more efficient that the browser engine actually understands. So the few things that we have heard from the core team are really interesting. We know a little bit about what it's doing, thanks mainly to this one. I noticed a few interesting things that I would love to discuss at another point in this talk, but for now I'm just going to look at the big blue circle in the middle, which shows what it's actually doing under the hood. So let's see what it's doing and see what we can learn. Given this code, it looks at which is surprisingly similar to the code I was showing you earlier, but it basically looks at the logic that is contained in this case, a hook, as a whole. And so in this case, what it does is recognizes that there are three dependencies, there are three pieces of data that could change the behavior, i.e. the two props and the one variable inside the component that's actually being used. The one that wasn't being used, you'll see in a second. So it creates memo cache, which is where the $0, 1, and 2 are for each of those. And then when it actually renders, it's just using really basic if-then logic or if-else logic, which is actually really quick to run and surprisingly easy to read. So it checks the props first. If they're unchanged, it recycles and shows the cache data, i.e. the cache value for X, which in my example is the intro line. And if either of those has changed, the props, then it recomputes them both of them. And the focus there being on is watching for both of them at the same time. So it's more similar to the pure version in the other example. So I'm just going to quickly look back at those examples so I can show you what I mean. So this one is correct because it's watching both of the relevant pieces of data. And I have actually taken it upon myself to rewrite this code in my forget memoized component. And this one is working just like the unmemoized version. And that means the behavior, i.e. the logic, is first and foremost correct. And so it looks like it's smarter than whoever wrote this impure code over here, which is fantastic news for us as developers. So what is the actual lesson here? Basically, take a step back from your code when you're about to memoize it and make sure you've got all of the relevant dependencies. I know there are linters for this, but like your brain is still good and still worth paying for on a day-to-day basis. So the second lesson, I think, is that it's not always just purity that you need, because in the example where the data was just not changing at all, it was pure, but it just wasn't, it didn't have the correct dependency array. So the main thing is that we should make sure that the UI is a function of its state and reflects its state accurately. And so, yeah, the lesson I took from this was basically take a step back, make sure you're covering the whole logic, but it's going to do some amazing stuff and make your code quite ugly so you don't actually have to. So another really cool thing it does, better than humans again, is memoizing JSX elements and components. So for example, a React memo can also memorize a component, but there are things that it does which we wouldn't normally do, like using a use memo, the equivalent of using a use memo within a component in order to memorize another component that's relying on data within that component. So can we learn from the compiler in this example? Well, I've seen people online already starting to recommend that we imitate this in this way, i.e. loads of these use memos, and in the dots, just assume there's logic, and it returns components, header, sorted list, and link. Well, look at the state of this code, man. Like, definitely not idiomatic React. Definitely brittle, easy for someone else to change, for you to forget a dependency or put in, say, an object into the dependency array, which, again, would rerun everything. And it might even break the rules of hooks, I think, if the components and listens are themselves calling other hooks in a dependent way, but we don't have time to discuss that. Remember, the compiler is going to make the code ugly, so you don't have to. So, limitations. I'm definitely up for this new compiler, if you can't tell. You could say hotly anticipating it, but it does have limitations. These are important because it impacts what we do now in preparation for that compiler. So what it's not going to do is actually improve your logic. If you've introduced actual bugs by, for example, abusing memo, the compiler is not going to change that. It's not going to change the behavior of your component. It's going to assume that is the expected, anticipated behavior, and it's going to just optimize that behavior and make it really fast. So the logic is still going to be your job. Something else that is still your job is going to be basically composition. And this is like the final point that I want to really emphasize in this talk. React already gives you tools for, I forgot to, correct this sentence, but basically, React already gives you tools through composition to prevent excessive needless re-renders, and that's called same element reference. If you're not using component composition properly, the compiler is not going to add composition to your code. It's just going to be able to memorize things. That's the limitation of it, and that's kind of a good thing. But it's going to have a cost. Memoization has the cost we spoke about at the beginning, which is memory, using it to save time. So avoiding re-renders sometimes just requires you to really use React. What does this mean? Very quick demo of that. So basically, this is a component. Everything above the dashed line is what I'm calling a header. This contains 3 React patterns. The one at the top I'm going to call unidiomatic, because the React team keep talking about idiomatic React. So when I click on this, then you notice that the only thing that changes is the words at the very bottom. Everything in the header stays the same. What you can see in the logs here are all of the components that are re-rendering, because each component used in this example logs when it re-renders. So here we've got 3 components re-rendering every time I click. Seems a bit needless, right? Given that a few words are changing on each click and the color. So this is what I would call like a fairly classic, this parent doesn't even really need to exist. All the logic is contained in this component. Basically, we've got the state hooks, 2 of them, and so we're updating the line, toggling the blue, and we've got the purely visual wrapper here. So it looks like we're using some composition. So what's going wrong? If we're not sure, we might be tempted to just memoize everything. So let's look at the memoized version. I'm going to clear my log. I'm going to do some clicking. Yeah, still got some re-renders. How fun. Basically, what's happening here is that we've memoized everything. All of the functions are memoized. I've got a use callback here. We've got a visual wrapper, which is itself actually memoized, but it's still re-rendering both of them. That's not fun at all. So yeah, the main thing to look at here quickly is what I'm going to call the idiomatic version of React. Look, I click and one thing changes, the idiomatic organism. How nice. This is how it should work. How are we doing this? That's what you actually want to know. So in this parent component, grandparent component, you'll notice there is no state. I will share this at some point if anyone wants to look through it. Basically, all of the static components, the visual one, the header, they're all kept at this top level. And the state changing components, i.e. this parent one, contains all of the logic, but like none of the static stuff. So they're like nicely separated. The state is kept really close to the things that need it. People often think when you say keep state local, it means like keep it down somewhere in a leaf node, but it doesn't need to. It can mean keep it in a parent, but that parent only contains the things, and this is quite congruent with what Elham was saying, only contains the things that need to be updated. And what's good there is that these children, which gets passed down from the grandparent, React knows that they're staying static because of the one-way data flow system in React. So props are read-only, and by just passing some of them forward, it knows they haven't updated. And so the only thing that needs to change is this conclusion. And then in this example, I didn't even need to memorize the purely visual wrapper because it just takes these static props and lets them kind of pass through it. So that's my final demo. You'll be pleased to know. I am. Basically, what I'm saying here is that we need to be really using React to get the most out of it. Here's a few ways of doing that. Keeping state local, and definitely not mutating state, especially global state, like variables outside of your components should not be updated from within your component. All these things are going to trigger horrible re-renders, as are classes. Sorry, I just hate them. And so my main point in this talk is basically, I think there's a reason why the Meta core team have come out every time they speak about the React compiler, they're talking about idiomatic React at the same time. And that is because to get the most out of the compiler, you're going to need to be writing idiomatic React. It has never been more important. React has this data flow for a reason. Make use of it. It makes your components predictable by machines and humans, i.e. the logical flow is obvious if you're using it correctly. Modern React, unlike old school React, has fewer degrees of freedom. It's been pursuing a pure functional model where it's just functions calling other functions, right? That lends itself really well to static analysis. And it also lends itself really well to working with your colleagues, I think. Basically, the reason why, what makes unpredictable code is impure functions, which cannot be easily analyzed by humans or machines because there's no logical order to those. So using idiomatic composition now will benefit you and the compiler. And idiomatic React, i.e. good composition and use of props, is going to be something which you can do right now and will still be relevant because, like I said before, the compiler is not going to actually do that for you. We can use these same element references. There's some really good talks just about that, which will actually prevent re-renders at least as effectively, as I hope I showed in the previous example, as memoizing things can. So often it's not even Memoization, which causes problems, it's actually use memo, but this is a rant for a totally separate talk. To conclude, finally, the React compiler is still a way off, so let's recap on what you can do now to optimize your code. Basically, first, check that your memoization is valid. Take a step back, look at the whole logic of what you're memoizing. And this will give you a cue about what exactly you need to watch out for. What is the relevant name tag on your tree that will mean you don't need to check every single bauble. The upcoming compiler can only raise the performance of your app. It can't fix any bugs. It's probably not going to create any, though, unlike you. Memoize at the highest level. That's takeaway number 2. And this is because, basically, you shouldn't waste your time tinkering with the low-level components that have loads of props. People are going to really easily send an empty array or something to it, break the whole memoization in the first place. Also, if they're not re-rendering that many things, it's just not that important. Memorize the top-level, expensive things that have trees below them that are going to be doing a lot of rendering work and slowing down your app. So don't sweat the small stuff. And finally, use React idiomatically. Localize state at the bottom and compose static components up at the top. So you might not need a compiler to forget memoizing, if you can forget about memoizing all for yourself. And the best part is that these things will benefit you and your team and the compiler. So when it does come along, finally, to auto-memorize our components. So thank you. I definitely went over time, so I'm sorry.
Thank you, Beth. We did tiny little bit, went out of time. It's fine. It's okay. We have time for a couple of questions, though, but good presentation. I'm just going to pop on this side, so I won't steal your thunder. So is there anyone that wants to make a question?
Not even where are all the images from?
Okay, I'm going to go for the Slido ones then. In computer science, caching is considered one of the most complex concepts. Memoization is a caching technique. How to learn memoization if you are new to React?
I mean, to link up with the next talk, I would actually say check out the new docs. They are just incredible. They explain how to do it in a very not academic or pretentious way, like how you can do it right now in simple ways in your React code, you know? And I would just, I suppose, not be too scared about doing it either. Create a sandbox, play around with things, see what updates and what doesn't update. There isn't that much risk. There is potential inefficiency that can come from basically the dependency array. You're telling React to check the dependency array and that nothing in that has changed as well. So if you use it too much, it could make things, ironically, a little bit slower because React might do extra checking of those dependencies, which it might not actually need to do. But you'll notice if you've created huge inefficiency whilst trying to optimize, I think. And those linters, man, they're great.
Okay, thank you. I'm going to go for the next one. Do you know if React team gave any hints on the build time cost of the new compiler for medium to large apps?
It's actually interesting because what's really relevant for your users isn't build time so much as the download time of your bundle. And it looks like, because we'll be putting less code, I will be writing use memo, blah, 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 less. And you've had a very quick look at some of the code that it spews out. And that is really basic JavaScript. It looks like it might actually reduce the bundle size rather than increase it. So it might increase the build time, sure. But you're not going to, what you don't want is the bundle size to increase, because that's what would prevent people with lower level devices or poor connectivity from actually downloading your JavaScript, app in the first place.
All right, thank you. Any more questions? If there's no more, There is one. Sorry. One more. There's a micro coming to your way.
Thanks, first of all, for the talk. It was very insightful. In the impure memoization example, I did not quite get why it was entering, like it was adding things twice. Is it because of strict mode? Because
Yeah.
I've not really managed to read the code. It's too far away.
No.
So is it because strict mode, I know like it renders things twice.
So the impure one. Yeah, so I actually was a bit confused by that myself, and then I realized it's just, so when you're in development mode, i.e. with strict mode turned on, then it just automatically runs everything twice to flush out impurities.
Not something else, right?
Huh?
So it's because of strict mode, not something else.
Yeah, so like it isn't because, so and it's a really good question actually, because like what is not happening is it's noticing that this first variable has changed and therefore like running it again within itself, if that makes sense. Just because it's watching it, because it's a mutation. So it wouldn't be able to notice that change. It's not looking at the value and saying, oh, it's materially different, I should update. It's not that, unfortunately, JavaScript isn't that smart. So it just thinks, that it's pointing to the same thing. What would actually happen in production when you press next line is that it would just keep adding. It would say there are too many words in most poems, and then too many poems, rather than the duplication, which is just an artifact, which unfortunately makes this a little bit less clear as a demo, but at least makes it more powerful visually. Just look at this mess. Anyway, yeah, this one.
Okay, thank you.